Well, I think it broke into two parts. So if that is the case, I'm back. All right. So let's share the screen again, and there we are. Now you should be seeing my desktop, okay? And here we have the problem that we're working on. This was example 11-2. And I mentioned in the previous video, unless I can stitch these together, that I had done step 3, had done all of step 3, and we calculated this test statistic here, all right? But I skipped steps 1 and 2, which are very important, of course. Step 1, of course, in any hypothesis test is to state the null hypothesis and then the alternative or research hypothesis. And if necessary or if possible, identify the claims. So here, in any of these goodness of fit tests that we're going to perform, the null hypothesis is always that the observed distribution fits the expected distribution. And so basically we can just write that. We can say the observed distribution fits the expected distribution. In the book's solution, you can see that they went in and spelled it out in long detail. The proportion of people is in each category is as follows, and they listed them all out. And then the alternative hypothesis would be it is significantly different than this, all right? Okay, and also we skipped step 2, which is pretty equally important, all right? So that involves looking up our critical value. So we have to go to table G, the chi-squared distribution, and the degrees of freedom that we're using for this are the number of categories. So there's 4 categories: some high school diploma, some college, and college degree, minus 1. So K minus 1, K is the number of categories. In this case, it's 4. So here we're looking at row 3 for our degrees of freedom. Alpha equals 0.10, and that gives us a critical value of 6.251. And then step 3, which we did in the previous video, is to calculate our test statistic. And you can see it is 3.53, and that'll round to 3.531, since that next digit is 9. All right. And whenever we find the critical value, we should always sketch the distribution. So here's a nice little sketch of it. Here's the area that we shaded in. That area we've looked up as 0.10. And so this chi-squared value right here is the one that we said, 6.251. If our test statistic is 3.531, where is that in relation to 6.251? That's to the left of it. So it's over here somewhere. So what's the result? Well, we're not in the critical region. We're not in the rejection zone. So we cannot reject the null hypothesis. What does that mean? Well, in terms of this null hypothesis, the proportion is as follows, or the proportion fits with the expected distribution. Well, we would say, well, there's not enough evidence to reject that claim. And so we would conclude by saying the proportion is not significantly different than as listed above. And that concludes example 11-2. It might be broken into 2 separate videos unless I can overcome technology and figure it out. So the other one might have cut off abruptly unless I can merge them together somehow. But at any rate, I'll see you in the next video. All right, goodbye for now.